After the overwhelming response from our last event, ESP Explore, conducted back in September 2023, we were just seeking for the moment so that the endeavors picked up by us, the networking nexus, could see the rise of a newer skill to be attained by you learners and get taught by us, your technical preachers. Therefore, I welcome all the dear participants to the second event of Networking Nexus, serving your app to millions, a guide to how big companies exactly do it. Today, we have gathered here to kickstart our journeys in learning the concepts of production techniques and to acknowledge our will to learn and teach. We all have been blessed by Dr. Revati Venkataraman, Chairperson, School of Computing, Dr. Shantanu Patil, Associate Director, DEI, Dr. R. Annie Utra, Professor and Head Central, Dr. M. Lakshmi, Professor and Head DSBS, Dr. M. Pushpalata, Professor and Head CTech, and our convener, Dr. Annapurni Panyapan Ma'am, Professor and Head NWC. Before we move any further, it would be a matter of immense pride for us if Professor Mukesh Krishnan, NWC, would address our audiences and welcome our speaker, Mr. Vasanth Srivatsan, on this very auspicious day.
Good morning. First, I thank our Students Association, the Networking Nexus, for organizing this event. And I hope we do understand we need so much of talents which are being required in the industry in today's era. And there is a biggest gap the industry need and the output which has been coming out of the institutions. And I hope apart from the curricular aspects, this kind of events which is going to be bridging the students to get into the industry or to carry out their startup career, or even they can able to be go for an higher studies in the well-best universities in the world. And I hope today we have Vasanth Srivastava, who is the lead, technical lead in the Infobot AI, who is here to stay with us for the whole day. And he has been well enough to provide the training for our students in the various aspects which are all not present in any of the YouTubes or which will not be available for you in the Google, or certain technologies which are all needed for you, as well as which are all the hot in the job market today. Those technologies he is going to teach you, and he will train you, and he is going to provide you a gooder visionary about those conceptual things like the dignified scaling, database pooling, microservices, load balancing. These are all some of the topics he is going to provide the training for you. And I hope you do understand the industry today needs more skills than what degree you are having with you. And the skill sets will be developed via this kind of trainings. And I congratulate the participants to be here to get this training or enabling yourself to get trained in this topics. And I'll also thank our speaker or the trainer who had been come all over here to train you. And also I will welcome you, sir, for this event. Joining the hands with the Networking Nexus, I welcome sir for this event. And I will also thank for all the organizers for organizing this event. And also we should thank the faculty mentor for this club, Muruganandam sir, and the Arun Kumar sir for enabling you to make this event to happen. And I also welcome all the students and the dignitaries and our guests for this event. Thank you.
Calling such enlightenment to us just words of wisdom would be an understatement. Networking Nexus is a student-based organization that targets IoT and cloud computing related endeavors. Today, this event, Serving Your App to Millions, would sure be a setting milestone not only in our but your journey as well. Putting no more further delay, may I call upon the speaker of the day, Mr. Vasanth to start this great day at this very great moment. Everyone, please give a big round of applause to Mr. Vasanth.
Before we begin, I would like to thank all the professors we have here, and the people who we have missed, our HODs, chairwoman. I would also thank them for blessing us with the opportunity to conduct this event. Okay. And once again, thank you, sir, and please, thank you again for supporting us.
Good afternoon, everyone. May I request your attention? I'm not a big speaker like a lot of people who might have come to the stage. I'm just an ordinary student like a lot of you. Just a little bit ahead, maybe. That also I'm not really sure. I have a lot of questions for you. And to get started, I'd like to ask you, everybody has used so many social media websites. You have used Facebook, YouTube, Twitter, Facebook, so many websites. Have you wondered how many people actually use these websites simultaneously? I would want an answer here. Have you ever wondered how the scale works, where there are so many computers and there are so many people that are using the app simultaneously, and all of you are still getting a smooth and easy experience? Today we'll be learning about how you have built an app. So many people must have already shown you on the stage how you can make an app, how you can build a mobile app or a website or whatever it takes for you to build it. But today in this session, I will be showing you how you can take your app and make it into a business or serve it to millions of people and take the greater good out of it, right? And I'll also be talking about how big companies do it. And also I'll be talking about how to make this into a better system where your app, you're able to serve it seamlessly. My name is Vasanth. As you can see on the screen, I'm a software developer, to be put simply. I right now work at a company called Introbot, where we make AI WhatsApp chatbots. And I've been doing programming for the past 10 years. And I have started programming basically in 2013 when I was in 7th grade. And from there, I've been doing C#, VB, WinForms. I've done Python, which a lot of you might already know. I've done JavaScript and so many other programming languages where I've touched. These were the ones that I've actually coded projects in. There are other languages that I've touched. Right now, before we start the presentation, I want to say one thing, which is stick with me, because I'm going to teach you something today that no YouTube channel will ever do, that no article is going to ever do for you. Because this presentation, I have compiled my entire 10 years of experience on how you can take your app that you've already built and scale it to millions of people in a single, in a single 1.5 hour presentation. So to get started, there may be a couple of important words, important terms that you may not know that I will be speaking, and I would love you to write those words in a notebook or save it somewhere so that you can come back and ask me in the Q&A session, or you can basically Google them and know better about it. The objective of this presentation is not to teach you something. The objective of this presentation is to show you that such things exist in our industry and how you can best use them, right? So to get started, I'd like to first cover some basics, because we have, I think we have a mixed audience here from all different years. So I'd like to cover some basics here. And there are basically 3 terms that are being thrown in the industry today randomly. Somebody says I'm a backend developer. Somebody says I'm a frontend developer. So I'd like to clear on these concepts first before moving forward and showing you the fun stuff, as I call it. So here we have 3 things. The web server, which is what we call as the backend. Then we have the browser or the client, or that is what we call as the front end. And then we have transmission. We'll go in brief on what these 3 things are. fundamentally, in a very basic, rudimentary way, like if they were in the 1990s. And then we'll move to the more advanced concepts. To get started, that's not the backend that I was thinking for. It's a different. Okay, that's the backend. That will suit it better. So first, let's talk about the web server and fundamentally what it is, right? As you might have seen a GIF, that's a server basically dancing. That's a restaurant server. A real server is very similar to a restaurant server, where you can ask a real server a couple of pages instead of a couple of dishes. A real server would show you a menu. You would select a few dishes from that you would like to eat. A web server is fundamentally very, very similar to that, where you're asking them, hey, I want this page, I want that page, and it is giving you those pages. It may be pages, it may be API requests, whatever it is. The fundamental idea of a server is the same as if it is a restaurant server. So it's a program that translates what a restaurant does, what a server does in a typical restaurant into the computing landscape. Right? So here we see a typical Express server. Now here again, I'd like to ask you, can you please raise hands for me? How many people know Express? What is Express? You have to raise hands to let me know. This is an interactive session. I have come here to talk to you. I have not come here to just say some random things and just, leave. So please, how many of you know what is Express? How many of you have heard Express? Okay, 1. Come on, 2. Okay, there's a bunch there at the back. Cool. Only few. All right. So let me first explain what is Express in that case. So Express is a web server framework. Now, what is a framework? It looks like some random, jargon term, to be precise. So what is a framework? So the concept that I've said of a server in a restaurant is very, very fundamental. And in computing landscape, it is much more complicated than simply, you are requesting and it is happening. Because for computers are almost like kids. You have to tell every single thing, instruction by instruction, for a computer to, do what you want. Right? So this Express is a framework that has a lot of things done for you, that has the schematics already there for you. You're just building what you specifically want. So that is what a framework allows you to do. And there are so many frameworks out there. You can just go to npm.js if you are looking into JavaScript, or you can go into PyPy for Python. And there you will find so many other frameworks, libraries. There's a huge debate in the tech community right now on what to call a framework and what to call a library. But that being said, you will find a lot of packages that you can install, you can build on top of. So Express is, very simply put, one of them. And here I'm creating an Express app, and I'm saying app.get/ and I'm saying it is taking the request that is coming in, and it is also getting a response that I will modify. So you can see I'm saying res.send, and I'm sending Google. Literally, this is what is there inside Google's servers. There's nothing crazy about it. I've seen even more complicated things. Ultimately, it just boils down to this, right? This is an oversimplification, of course. It's not as simple as that, like you would write a 3-4 lines and, it does your job. But fundamentally, when somebody asks you, okay, what is a server? This is what happens in the background, right? So this is a server. And next to that, you will see we have a browser. That is what is called the client. This is the customer in the restaurant that wants to have something. Why does it want? It may want because you, as a user, is asking. Let's say you want to browse Instagram, and there is an Instagram images server that is specialized in giving you images at the speed, at a sensible speed, and that too for so many people. Right, so over the course of this presentation, you will get a much better understanding of how you can take this one simple app that you've built and make it into a huge website where so many people can use it. Right? Now, getting back, this is the client. And now client doesn't always have to be a browser. How many of you know about curl? C-U-R-L, curl command. Okay, 1, 2. Only 2 people, 3, okay. 4, 5, okay, cool. So we have a couple of people. Yeah, so curl is also an HTTP client. Anything that requests or that talks to a server says, yeah, I want this particular page, is called a client. So we have two things, the server, which is what we call as backend. And you might have heard about this field called backend engineering or backend developer. Essentially what these people do is they write code that belongs to this side, the back side of a website, the back side of a product, right? The back side of an API. Ultimately, those people are called backend engineers. That's the actual definition of a backend engineer. Now, for front-end, people who take the raw information and show it beautifully are called the front-end people. And it is not necessarily showing it beautifully as a website. You may have an API where you have to, you will have a lot of information in the database and you want to show it in a sensible way. In a single page, you want to show how many blog posts there are, you know, how many pages totally there are, what are the tags that are being used. That is the job of a backend engineer, right? And for the front end, it is mostly web, but does not basically restrict to web. You can build games, you can build apps, and these all come under front end as long as whatever is happening, that you are writing code, whatever is happening in the browser. Now, a lot of people seem to not be able to differentiate between backend and front end. This mostly happens with you know, a lot of people who have just gotten into programming. They're like, okay, backend, okay, front end. What is the difference between them? This is the difference. And there is also one more giant beast that you will have to learn, which is called transmission. I hope I've got the right slide. Yeah. So that is called transmission. Now let me quickly explain what is happening. I've just written a few points here in this paragraph. Let me quickly explain what it really means. Right? So you open your browser, be it Safari, Chrome, Firefox, whatever it is, and you type google.com. That's the first point that is happening there. From google.com, since computers don't understand words as it is, right? Because they understand binary, as a lot of you people might have heard in your classes. They need to first get converted into a number. Let me give you a good example. Let's say you have a friend who wants to meet you. Right? First, they're going to call you. This is that call where, you know, there is a server. Its whole job is to take google.com and spit out this random 142, 251, 175, 113. I'll give you a quick exercise. How about you type this in your Google Chrome and see what happens? It'll be very interesting. Just open your Google Chrome, type http://142, 251, 175 and 113 and see what happens. If it is working as expected, it'll go back to google.com to prove the point, right? So that is what happens. And now Google is such a big website and they can't just run based on one simple you know, web server that you all have. So Google has an internal network. It's not just one server that is running. They have an internal network of multiple servers. And randomly one server will decide. I'll talk about what this random thing is going forward in the presentation, but randomly one server will be assigned. So that 192.168.0.223 is the actual internal server address. So what we call as LAN IP or an internal IP. The top one is what we call as the public IP of Google. Every website will have a public IP. Some of them mask it, it's a different thing, but every website ultimately will have an IP where it is reaching for. IP is like the address, it's like the address to the home where the web server is. Now, this is what happens, and this is very, very important when it comes to serving your website to millions, because changes do not happen in the back end, changes do not happen in the front end. When it comes to scaling your app to millions of people. A lot of changes happen in the transmission layer, and this is how it goes in gist. Now I've taken a few words. Basically I've explained DNS, domain name system, in common. You can just Google it to learn more about it, or you can ask me in the Q&A session that we'll be having in the evening, and where I'll be able to elaborate you in a much broader way what is DNS. There are different types of DNS and a whole bunch of that. Now, how do we do it for millions? There are generally two ways to do it for millions. And first way is what we call as vertical scaling. And the second way is what we call as horizontal scaling. How many of you have already heard about these terms? Okay, couple of people. Interesting. So there are two things, like I said, there is vertical scaling and then there is horizontal scaling. To be put very simply, vertical scaling is you have a server and you are making it powerful. It's like going to gym, to be very simply put. Like, you're gaining a lot of muscle and you're becoming powerful. Things that you couldn't do before, you're starting to do now. That is essentially vertical scaling, where you have a computer, your app is running on that computer, you're adding more and more and more resources to that computer to be able to handle more people, to be able to handle more users for that app, right? Then there is horizontal scaling, where these are steps that you would take. Essentially what happens is, with vertical scaling you can get up to 100,000 users, and from there even vertical scaling does not work, where you will have to work on horizontal scaling. So let's look at the steps that will go in vertical scaling, and then we'll look at the steps that will go for horizontal scaling. For horizontal scaling there are more steps. It will be a little more complicated. For vertical scaling it will be very, very simple, and you will see how it can make things much better. To get started, vertical scaling is just like that. Like I've said, vertical scaling ultimately boils down to, you have a computer, you want to use the resources of your computer in the best possible way. You don't want it to stay idle and not do anything, but still not serve your users. That's the first drawback, where so many people, they build a backend, they build an app, and when you put a debugger to it, when you attach and when you analyze what is going on, you will see 90% of the time CPU is sitting and chilling. It's idle. It doesn't actually do work when incoming HTTP request comes. When let's say for example you make an app like Instagram. When somebody asks a photo, then you are serving a photo, right? But a lot of times what happens in these applications is, somebody has requested a photo, but that photo is taking too long to load. So now your user is seeing a loading screen. It's loading, but it never finishes, or it finishes so late that the user has lost interest in that. First, very big problem. Making your app faster leads to vertical scaling, where you're using the CPU, you're using the RAM, and you're using your storage more efficiently. It's not only just building the apps, it is building the apps efficiently is what differentiates a developer apart. Like how good you can build it, because everybody can build today. You can see, for example, you must have already seen ChatGPT, right? It's going to take 50% of jobs. Well, I don't believe in that, but that is what a lot of people are saying, that ChatGPT will take so many jobs. Now, how do you differentiate between you and ChatGPT? If I give a simple prompt to ChatGPT today, as is right now, you will see it will try to install dependencies that don't even exist. Absolute hallucination, right? It looks funny to me that we built a product where it doesn't even know how to produce sensible code, because it doesn't run code. It is just predicting, okay, what word will come next, what word will come next. It doesn't understand the concept of it. We understand the concept of it as engineers, and I believe that our careers are completely safe even with AI, because at no point will it be able to understand the concept of it. Right? That ability to understand the concept and do it is only in humans, and it's a unique trait for us. So that is what is vertical scaling, and there are a couple of terms here that we'll explain going forward, which is making your app modular and making your app fault tolerant. This is just an introduction slide, so I'm not going too depth into it. We'll have more slides because we have good amount of time, where I'll explain what is making your app modular, what are the benefits of making your app modular, and what is fault tolerancy, and how does it work. But basically, vertical scaling, the definition means you're making your app most efficient to run on your computer, and on top of it, you're adding more to it. Let's say, for example, your app is there, you're serving 10,000 people through this Instagram clone that you have built. Now, you want to serve 100,000 people. So what do? You obviously add more storage. You literally bring hard drives, you add those hard drives. That is what is called vertical scaling here, where you have a computer, you are upgrading it to be higher, and higher, as long as it's possible. Now, the first thing that we can do is asynchronous programming. I know my presentations are a little weird, isn't it? There is not a lot of content there, and it is intentionally done such way so that you remember the GIF and you remember what I am saying instead of reading something out there. Now, asynchronous programming is all about being busy. Very simply put, let's say you make an app, and I'll take a simpler example. The lady here is trying to cook something. let's say you're cooking biryani. You have to prepare two things. You have to prepare the biryani and then you have to prepare the curd thing, which we call as raita, right? So in this, generally synchronous programming is where you are preparing the biryani first, then you are coming to prepare raita. Let's say for preparing biryani, you are taking 1 hour. For preparing raita, you are taking 20 minutes. To prepare the entire thing, it is taking 1 hour 20 minutes. You are basically doing it in a linear way. That is what is called as synchronous programming, right? The synchronous way of thinking. There are synchronous languages that offer this by default, but any programming language is like a tool. You can bend this here and there, do whatever you want, right? So that is the ideology of synchronous programming. Now, what is asynchronous programming? This is where you are doing two things at the same time. While biryani is being cooked, you are going and preparing raita. So ultimately, your entire task is finished within the same hour, and you are not taking extra time to do whatever you are already doing, right? So that is asynchronous programming, where you are not letting your processor, if I talk in technical terms, you are not letting your processor do nothing. It is always doing something. If not this task, you are dropping this, doing something else, coming back and picking this up when it is ready. That is the basic concept of asynchronous programming. Or this question may be asked to you a lot when it comes to JavaScript. JavaScript fundamentally works by taking the asynchronous principle. That is why it is much more performant compared to something like Java or something like C, C++ when it comes to building backends. Because JavaScript by default is already asynchronous. You don't have to separately write code for it. You don't have to separately do anything. Right? So that is where the benefit of asynchronous programming is. So first thing, if you want to make your app much more performant, the first thing that you do is make your app asynchronous. Your CPU, even if you have one CPU, it should be working all the time. It should not, when the request is there, it should not keep other people waiting. Your architecture design must be like that. The way you are designing the application. Code anybody can write, even GPT can write, and I'm not even talking about it, right, at this point. The architecture must be such way. Then the next thing that happens is multi-threading, where you have multiple things, multiple processes that are running at the same time. If we take the same example of preparing biryani, this would be two people working to create two biryanis, and when there is free time, they are going back and preparing raita. So it's much more scalable than having one person. Now we have two people who are actually, well, the second person does not seem to be working though, but that is the GIF that I could find, so I've added it. So as you can see, that is two people. That is called multi-threading, where as per your app's demand, the more people you are getting, the more threads you are spinning, and those threads are also working. And there is a difference between asynchronous and concurrency. A lot of people, when you code, when you create a practical Python file with asynchronous and threading, or when you create this with JavaScript, you will see both look same to the eye. They are exactly same when you look at it, the outputs, right? But it is significantly different. Asynchronous is one cook doing things much better. Threading, having multiple cooks doing things much better. There's a big difference. With threading comes concurrency. Have you heard of this word? Concurrency. Right? Doing things at the same time. Don't mistake asynchronous things with concurrency. Asynchronous is when your processor is idle and so you're putting it to better use. Concurrency is when you're actually doing things at the same time. There's a lot of complexity when it comes to multi-threading and asynchronous and concurrency. We'll go about those topics going forward in the presentation. Right? Then the next thing that comes to us is queues. How many of you have heard about queues? You've heard. Very good. 2 people. Wonderful. How many? Okay, there are a few people that have heard about queues. Queues is basically, don't just do things, put them in a queue, wherein what happens is, let's say for example, you built Instagram. Now somebody is there, they've posted 1,000 pictures in Instagram. Now you want to delete that user. I mean, the user themselves want to delete the profile that they have. How it would go is, if you didn't have any queue system, you would start to delete all those photos right now, and it wouldn't be instantaneous, right? It will take a couple of hours for you to delete those photos in your server. Obviously, even it takes for Google. Then how is Google doing it? How is YouTube doing it very quickly? Like they take For every minute, they take almost 15 terabytes of YouTube videos for every single minute from all over the world. Let's say I want to delete my video. It's very simple. I just have to click 3 dots, delete, and boom, the video is gone. How? It is because of queues. Queues make it possible, where it doesn't delete actually, it puts it in a delete queue, where a separate server, its sole job is there to simply delete stuff, right? Whereas there is a separate computer, its sole job is to delete, and it is put in a queue. Just like how these people are getting their faces painted. Again, I'm sorry, I'm really bad with getting GIFs. It is how this works, where things go into queue. There will be workers or worker threads that will do the jobs in the queue, and instead of deleting that person outright, as soon as they click on the delete button, you mark them as delete. And that technical term behind it is called soft deletion. Have you heard about it? Soft deleting things. Right, very good. Now, these soft deleting essentially means you have marked them as delete, and you've put them in a queue where they'll be deleted whenever you have free time, whenever you have some resources in the server, right? But it doesn't happen instantly. So doing everything in a synchronous way, doing everything step by step, a lot of people say programming is basically instructions. It's like a recipe, you do step by step. That's actually not the case when you scale things up. It completely changes, right? When you're making a simple hello world program, it's simple. You print a hello world and okay, program done. Now that is not how it works. When you want to make an app that is really usable, that is really usable for a lot of people. So it's not as simple as simply writing a recipe, where you have a queue, you soft delete that person, and there is a separate computer that is deleting that person in background. That is a separate job. That's a separate program that is deleting this person in background, and you are just marking that profile as deleted. Today, so many apps are there that use this technology, where it is just marked as delete. It doesn't actually get deleted. That is called soft delete, and it's a common example where queues are used, but queues are used in several other places. How many of you have uploaded a YouTube video? Raise your hands. Oh, so many YouTubers are here, huh? So many people for me to make friends, because I'm also a YouTuber. Cool. So here, that is one of the examples where, you upload a YouTube video. You might have noticed initially that the video doesn't appear in full quality immediately. It takes a couple of minutes. That is because it has been put in a queue. Your raw video that was uploaded has been put in a queue, and there is a separate computer that is going on and converting these videos in all the different formats. It is not magic. It happens actually, and I was in Bangalore, and I've actually seen it happening in my face when people were actually putting videos, and I could see the backend of the YouTube website. And then we have, after all of this, it's a single computer. How much can you scale? There's a limit of how much RAM you can see. I have seen in production grade servers of IBM and Red Hat, I've seen servers that have 128 TB RAM. But you can't add more than that. How much, right? Even 128 TB gets filled if you made a really good app, because people want to use it. You want to make money out of it, people want to use it, and even that is not enough, right? Your hardware you can't just keep adding hardware to it. There's a limit of how many processors you can add. You can even add multiple CPUs to the same motherboard. If you've seen in some of the server side photos of motherboard, you will see one motherboard will have 2 CPUs. Right, so those are very high-end, expensive hardware that they are meant for vertical scaling. Basically, this is what it means. Now, for that as well, you can't just keep adding hardware to it, and that is what leads us to horizontal scaling, where you want more power than a single computer can ever provide or money can buy. Right, so that leads you to optimizing or having multiple computers that are optimized. So first, you take your app. You do vertical scaling, then you do horizontal scaling, and have multiple optimized computers serving your app to millions of people. This is where our common social media websites and common things that we use are actually in this stage, where they are horizontally scaling at this point. Vertical scaling is not even a thing that they care about at this point, because they have so many users, a single computer just simply can't handle. And there are other reasons for horizontal scaling as well, which we'll talk going forward, right? Now the next thing that we have is load balancing. This is a special topic that we have because we'll have a practical session on this topic where I'll show you how easy it is to actually build a load balancer, right? It'll just be happening in 10 lines of code. And when it works, you will see a big difference in performance, right? So load balancing is essentially you have a app, it is working well, you have vertically optimized it, and it is very efficient. Now you want to copy this app into multiple computers, starting with, let's say, maybe you want to have 5 computers, right? 5 different computers serving the same app, connecting to the same database, and basically doing the same thing. But you have so many users, so you want to distribute those users across these 5 different computers, and that is where load balancing comes, right? There are different algorithms that are used. Algorithms are basically like written recipe, right? You might have seen what is basically a map. A map is basically an instruction set on how to go somewhere. An algorithm is exactly a written instruction or a theoretical instruction. It's not a practical implementation, it's a theoretical instruction of how to do something in computers. That's what we call as algorithm. So many people will be like, yeah, I've heard about MD5 algorithm, or I've heard about SHA-256 algorithm, right? It's a recipe that they've learned how to follow that recipe, right? Now, in load balancing, there are several algorithms to tell how to distribute the traffic that you are getting, how to distribute the users that you have between several computers, because it's not as simple as that. If you just throw them at one computer, then that one computer will be full, other computers are again idling. If you throw them randomly, then each person every single time will go to a different server that will not have any context about what the user is actually doing, right? So there are different methods. The method that I'm showing in this GIF is called round robin, where the first request is sent to the first server, the second request is sent to the second server, third to the third server, and so on and so forth, until the servers are over. Then it will revert back to the first server. So that, let's say you have 5 computers, they all will have equal load on top of them. This is the most simple example that you can use, the most simple algorithm that you can use, round robin. And in a lot of load balancers, it's by default built in. You don't really have to do anything. It is already there, and that is how it works, and that is how round robin works. The GIF basically represents the algorithm that is followed. There are other algorithms that we also follow, like for example, least connections, or what we call as LC. This is what a website that I recently built uses. LC is an algorithm where, let's say you have 5 computers, right? And one computer is having only 20 people. It is only having 20 requests that it has to process right now, whereas the other ones are having 100. When you are using the LC algorithm, it will divert traffic to the server that has the least amount of work to do, right? Basically, it will give work to the laziest server that is out there, if I have to put it in a very layman terms, right? Ideal if you have 5 servers with exactly the same configuration. You have 5 different computers, they have the same amount of RAM, they have the same amount of storage, and they are doing exactly the same thing, then LC will work very good. Although round robin also does perform in a very similar way. When you have the same weighted servers, right? Now then you have WLC, weighted least connections. That is again another algorithm, a method of distributing your users across multiple servers. This method is where, just like LC, it is more flexible, right? Where you can assign each server a number, and you can say this is a very bulky server, it's a very beefy server, it has 128 terabytes of RAM. So give it 80% of the traffic and divert the 20% of the traffic that you have, which is the thing that the big server is not able to handle, into a different server, right? This is by assigning weights. That algorithm is called WLC, or weighted least connections. These words are important for you, huh? Please note down these words, because I'm not going to explain up to the full depth. I'm here to show you that such things actually happen. How they happen, how much should you learn, depends on how much you are interested, right? Within 3 hours, I can't just say everything. I mean, given the time constraints that we have. So I'm just exposing you to things that, such things actually happen. The intention is not to exactly show you. So if you're writing something, then please go ahead. Then we have database pooling. How many of you know about this? What is database pooling? I am expecting at least few people will know about it. Okay, one person, very good, database pooling. Beautiful. And anyone else? No? Database pooling is where, let's say for example, you have to talk to a database, you have to see how many users are there in your app, how many photos are there for a user. You will obviously store those people in a database, and there are different types of databases. To talk to the database is an expensive thing, because you have to open a communication channel. You have to open a connection is what we call it as, right? You have to open a connection, then talk to the database, ask, hey, this is the user ID. How many people are registered with this user ID? And it would be like, hey, I have this person who is registered. Their phone number is this, their email ID is this, their username is so and so. That is how it works. Now, opening these connections, when you have only a couple of users is not a problem, opening these database connections. But when you have multiple servers, let's say I have 5 servers. 5 servers have 5 different connections to the database. Then it is very hard for us to manage when this 5 becomes, 5,000. So for that, and it is very slow as well. Like I said, it's an expensive thing to talk to the database. So what we have here, the concept is called database pooling, where there are ready-made connections, database connections that you can simply pull from the pool which is already there. Pool is basically you have a couple of connections in a memory somewhere, and you're just reading out of them. You're reading the connection, asking it, hey, how many people are there, and you're putting it back. Now, I'll give a great example here. Imagine it is your birthday, and you have a great shirt to wear. In this, if the shirt, you don't have it, if the shirt is not open from the box, you have to first open the box, take out the plastic wrapper that is there, and then you have to cut the price tag. It's a big thing, huh? You can't have the price tag hanging around like that. So you have to cut the price tag, then you have to wear it. It takes a lot of time to do all of this. Imagine if pooling is where your mom has already, your mom has already prepared the shirt for you. It is right there. You just simply have to wear it and go chill. Right? It is like that, where 50% of the job is already done. You have a database connection ready for you. There are set connections that are already there in that pool. Your app, when it actually requires a database connection, is just simply plucking it out, doing what it has to do, and putting it back again. And there are multiple servers. When they require, they'll pluck, do what they want, and put it back. That is what is called database pooling. And there will be multiple, basically multiple connections. You can tell how many connections do you actively want. I want 5 connections. Then there will be a pool with 5 database connections. You want 10. Then there will be a pool with 10 database connections. And 10 different servers can use these connections simultaneously without having significant performance drop, instead of just connecting to them individually every single time. And then you have a very big beast, autoscaling. How many of you have heard about autoscaling? Or how many of you understand just by the wording of it? Okay, I see a couple of hands raising. Autoscaling. What is autoscaling? How many of you have heard about autoscaling? Every company does this. Every single company at some point has to do it, and some engineer is going to sit and do this autoscaling job. And if it is you, it's very good, because you get paid a lot when it comes to autoscaling, because it's a very sensitive task as well. Now, let me talk about what is autoscaling. And there are a couple of things to keep in mind when it comes to autoscaling as well, right? So, to get started, autoscaling is the process where, let us say, right now your app is getting used by 10,000 people, and tomorrow is a holiday, and suddenly 1 lakh people start using your app. What would happen to the servers that are handling it, right? With autoscaling, what happens is that automatically this autoscaling system would create the required servers to handle the load. And when the usage reduces, it will again delete those servers. So it's all happening dynamically, where it is creating more servers for you, and it is closing them also without any human intervention. It is so cool when it happens, random servers simply pop into existence in the cloud. It will be, of course, it is not going to be free. You will be billed for it, but random servers will simply pop because more users are using your product instead of making your app slow. So performance, to handle large performances, we use something called autoscaling. And in autoscaling, there is also scale to zero, where if nobody is using your app, let's say your app is not so great for obvious reasons, then what you would do is, if you enable autoscaling, it would actually reduce your cost, because autoscaling has recognized that there is no one using your app, so it will completely shut down the server. Not even one computer will run your program, and they'll be used for better purposes, right? And suddenly, if say 10,000 people start using it, it will again scale up, and this happens without letting the user know a single thing, right? It is so fast, it happens in the background. That is what is called autoscaling, creating more compute resource on demand when you need it, and closing them off when you really not need it. Then we have microservices architecture. My God, how many people have heard about it? So I'm expecting good amount of hands here. It's a very common term. So many people will be like, I'm a microservices architect. I'm like, what do you do? I'm like, I don't know. How many people? Very few. Okay, couple of them in the back. Cool. And nobody on this side. Microservices architecture. It is basically the process. You build your app in two ways. Important point to be noted down here is, I'm never talking about how you have to code the app because it doesn't matter, to be honestly. Important thing is how you are actually creating the architecture of it, that design of it. You must have heard about a field called system design. How many of you have heard about it? System design, right? There are good number of people. This is system design. This is exactly what I'm talking about, right? Where it's more about how you design than how you code. Code is simple programmer. You give him, make this feature, he'll make this feature. An architect, an engineer has to design things, not just code things, right? So there are two designs here of two kinds of apps. The first one you see is called a monolith. Monolith in basic English is generally a single stone that is standing by itself, right? Where you have the UI, the front end, then you have the business logic, that's the back end, then you have your data access layer, or essentially they're unnecessarily complicating it in this photo, but it's essentially your database. Three things, right? And this is called the monolithic architecture. And with horizontal scaling, you can have multiple servers that do everything, right? They're not specialized. They don't do one specific thing. They are all do the same thing, and the traffic is being diverted between them. This is horizontal scaling with monolithic architecture. Then there is a microservices architecture, where let us say you are making a marketing application, like Amazon. You're making a clone of Amazon, let's say, for example. In Amazon, the checkout process is handled by a completely different server, completely different app. Even the UI is done by a different developer in a different framework. It's a entirely different code base, right? And to the user, it feels very seamless. They don't know that it's a different app, but we know it's a completely different thing. And that is what is called as microservices, where you're splitting your app by functionality into different chunks. So one is where sellers are adding their product. One microservice would be to list down all the products for people who have not signed in. One service would be to customize the products and list them for people who have logged in into Amazon.com. Right? So like that, there will be different services, microservices, as it is showing, different servers, small servers. Instead of one server that is doing everything, small servers that are doing very specific thing. This is very advantageous, and this is how a lot of companies have started to do these days. There are a lot of benefits for taking this approach. One big benefit that is that, let's say, for example, in your monolithic architecture, your business logic has gone down. There is a bug, your app is not working anymore, you can't do anything. All of your, let's say you have 5,000 servers that are using monolithic architecture, scaling through monolithic architecture. Then if there is one bug in your API, entire 5,000 servers will go down. There is nothing you can do about it, right? Unless you go and quickly fix that. With microservice architecture, let me come back to the Amazon example. Let us say the checkout page is not working. The website is still completely functional for those people who have not signed up, because that is handled by a different server. You must have heard, you must have read, there is a word called fault tolerancy. I've written it in the beginning of the presentation. That is achieved by microservices architecture, where you're splitting things logically instead of splitting things by size or by simply just making replicas out of it, right? That is microservices architecture. And you can see in monolithic architecture there's only one database. With microservice architecture there are multiple databases from different providers. One is in Google Cloud, one is in AWS. So even if one database goes down, your entire app is not going down. Just specific chunks of it are just going down. And it is never, your entire app is not going to go down. So that is what is called as redundancy or fault tolerance. How much your app can sustain crashes, how much it can sustain, let's say somebody is trying to hack your app, how much it can sustain, that is very, very important when you're giving your app to thousands of people or millions of people, right? That is that. The next thing that comes is caching. How many of you have heard about caching? There you go. That's what I'm looking for. See, so many people know about caching. It's a very simple term where storing an expensive computation, right? I'm going to give you an exercise right now. You can use your calculators, by the way. Please calculate and tell me what is 27 into 27. You can use your calculators, no problem. I'm not good at math. I know I have to use calculators, so you also can use calculators. What is 27 into 27? Right, 729. That is the correct answer. And now I'm going to ask the same question again. What is 27 into 27? You were supposed to say it faster. 729. Now it is faster than previously, because now when I asked you the same question first time, you had to calculate. If you were good at math, you would calculate in your brain. Otherwise, you would have simply taken out a calculator and then started calculating what is 27 into 27. You would have at least tapped some buttons in the calculator. Caching is the process where you're not doing the operation but you still have the result. Where next time when I asked you, second time when I asked you what is 27 into 27, you just had it in your short-term memory. That is a cache. And every computer has cache in so many different levels to make it much faster, right? And next, when you had it in your short-term memory, you just had to say, 729. Simple, you're done. You don't have to recalculate it again, right? So that is the fundamental idea of caching. And there are different, caching is general computer science, it's a general computer science thing, it's a general computer science term, but there are different ways, different types of caching. So let's go through each one of them in a very brief and easy way. First thing that you have is algorithmic caching. This is caching that you can use anywhere in your app. Let us say you have, you are making again an Instagram app and you are making a system where people can tag other people in the photos. You don't want to read all the people that you have in your database every time somebody wants to tag. So you cache them. You put them in a space where it is faster to read. Where it is faster to simply, instead of typing 27 into 27, it is faster for you to grab the answer out of it. Simple, right? That is called algorithmic caching. Generalized caching, where you can use this anywhere in your app, in the code, right, to make things faster. The function is taking 4 seconds, you use caching, now it is taking 300 milliseconds. That is what is called algorithmic caching. And in algorithmic caching, there are again 3 different algorithms. There are thousands of algorithms. Even you can create your own algorithm and publish that algorithm and it will be in a PhD. But there are mainly 3 types of algorithmic caching. I'll quickly go through all 3 of them. First one is LRU, least recently used, very commonly used in Python. This is where I've seen it in the wild. But LRU is basically, you have a function, you apply LRU caching to it. Next time when you give it the same arguments, it will not run the function. It will simply return the result from the cache, whatever is the result. So this is LRU caching, least recently used. So it will remember, let's say, the past 50 or 100 or 1000 invocations of the function based on when it was used. That is how it is going to pick up whether it should be in the cache or whether it should remove from the cache. Removing from the cache is also a very important thing, because let's say you have, again, let's go back to the same Instagram example. Let's say you have an app where you are allowing people to tag photos, tag people in the photos. Let's say somebody suddenly decided to delete their profile. You have it in their cache. Now what to do? It's a problem, right? So for such things, having cache, as much as having a cache is important, deleting that cache is also equally important, because if you don't, this is technically called cache busting, where you are clearing things from the cache. This allows for two things. This allows the data to be given, to be read again freshly in case it is changed, and this also allows your cache to not grow infinitely, right? Because now the more and more users are tagging, your cache will just keep growing, and it grow to so many petabytes, you will not know where to put the cache to. So to have limit on how big your cache should be, these are the algorithms. One is least recently used, LRU. Then the second one is called LFU, least frequently used, like how frequently you are running that function with that specific arguments. If you apply this, if there is a thing where specifically it is running like 50 times out of 100 times, then that will be cached like that. You can configure how many times it has to be used with that arguments, then it will get cached, and for how long. Then there is FIFO. FIFO is what we call it as. It's again a technical term where FIFO is first use, first out. So it's basically like a list. Next time you invoke a function, it will be put into cache. If it's in cache, it will be used in cache. If 50 items are allowed, then the bottom item will be removed and one more item will come in the top. That is caching, right? That is algorithmic caching. Then we have content delivery network caching. This is what makes websites faster, very simply put. Let's say you have an image, but the image is in US. It takes time. It takes to travel with the speed of light, right? That much time it takes for us, provided we have absolute excellent network, internet. That is how much time it will take for us to load the image from US, America, to India, here where we are right now. What happens with content delivery network caching is, there is a server which is there, let's say in Mumbai, in India, that is having a copy of these images, right? So instead of pulling those images from the US every single time, you are pulling it from a content delivery network, where there is a server that is specifically there near you, and it is giving you images, videos, API responses, websites from near you instead of going to the actual server. That is called content delivery network caching. Then there is database caching. Let's say you want to load 500 users and their Instagram photos, for example. In that case, what would happen is it would take significant amount of time to load those people and to execute the query. You can do it once, you can do it in the background, but you can't do it so many times. So your app again will get slow. That is where we would use database query caching, where once you run the query, we know the result and we are not going to rerun the query up to certain time. Again, you combine database caching with algorithmic specific caching. So you can bust the caching when it is required, right? Then you have then you have client-side browser caching. This is very simple. You visited a website, your browser recorded that you visited a website, and your browser knows, and it is saving it on your computer, a copy of the website. Only the front end, how it actually has to show up for you. That part it is saving. That is called as browser or client-side caching, right? So these different cachings that you can implement in your app to make it much faster than it is actually, right? Then you have logging. We are pretty much actually done. We are almost at the end of it. We just have, I think, 4 or 5 slides and we are done with this presentation. So the next thing you have is logging, where logging is very, very important, because when you have thousands of users in your app, they are not going to come to you and they are not going to say, hey, this part of your app is not working. And the app would be so complex that you just can't go and simply fix. You wouldn't know magically, right? So some way should be there where you know all by yourself that, okay, this part of your app is not working. And that is where logging comes. And there are different levels, there are different stages of logging. But for now, we'll go through 4 points. Number one, log collection. You put logs in your application, and there is a separate program that will simply collect all the logs that are being spit out or that are being generated while people are using your application. And one of the engineers will basically go and look at the logs to see if everything is right, if everything went right or not. It's like a record of how things are happening. And then you have log storage. Let us say your website got hacked 30 days back, and now you know that, oh, it is hacked 30 days back. How do you know about it? You know by looking at the logs that were there 30 days back, right? But since logs are expensive and big applications generate thousands of megabytes, thousands of gigabytes of logs every day, you can't store them in the same application. Otherwise, the log app will become slow. So they also have an optimization where after a certain set of duration, those log files are given to you in static text files, right? And it's basically like you download from Google Drive at that point, where they are saved, where they are stored, and you can't actively search them. You have to download, use your tool, and pinpoint on from which date to which date. That is when you will be able to look at it. This is called logging. And then let me cut it short. Then there is alerting. Log visualization, to be put very simply, is building graphs on how many logs you have, how many crash logs you have, how many warnings you have, how much info logs you have, like that. That tells a lot of information about how your app is performing in front of millions of users, right? Then you have alerting. Alerting is very simply put, getting the right developer notified for the right system. Because when you have such a complicated app in production, YouTube is not a one-man show where, a single person is developing the app and it's only that person. So different parts of YouTube fail, and when they fail, different people are actually sent messages, alerts, that, hey, the part that you've built this particular area has failed. So please come back and fix them. That is called as alerting. It can be very simple as you just getting a message when you receive a warning, or it can be as complex as there are 1,000 developers who are working and will only notify the appropriate team that has developed that feature. So it can be very complicated or very simple. I'm just letting you know that such things actually exist and they happen when it comes to the industry, right? So that is alerting. Let's move forward. And then there is feature flags and A/B testing. A/B testing, how many of you have heard? I'm guessing a couple of people must have heard about A/B testing. How many of you have applied for beta software? This word beta, this fun of using the latest and the greatest software, and you always update as soon as the new version releases, right? That sort of comes under A/B testing, where a set of users are separated. For them, we show a different a different app, a different product, a different software, a different code runs for them, and we'll observe if people are actually using it, and is it making it better for them or is it making it worse for them. Selectively we'll do, right? That is called as A/B testing. Now let's talk about feature flags. Feature flags is where let's say you have a very, very big app. A lot of things are depending on each other. You just can't release a new version simply like that, and because it will break a lot of other things that are around it. So what you do is you use a software like this that is showing here. It's an open source software called Growth Book, right? It's a feature flag software where your app has these feature flags. Basically they are switches, right? And each feature that you're adding is added being behind a switch. So if it doesn't work in production, till the time a developer comes, looks at the logs and figures out what is actually wrong, this feature will be disabled. Simply they'll just flick the switch off and you are sorted, right? And that is what is called as feature flags. So you can have multiple switches like this. You can enable different switches for beta, you can enable different switches for alpha. You have different versions, and that is exactly how it goes. That is how basically beta apps work under the hood. They have different set of feature flags. Now you have release management. What is release manager? How many of you wonder what the version number means? This is some 23.2.7.4. What does it mean? How many of you wonder that? Right? Now there is a meaning behind that, and a pro developer can simply look at the version and say, okay, this version has so and so new features, so and so bug fixes, and they'll just simply by knowing the number they can tell a lot of things. And this versioning system is called as SEMVer, or semantic versioning. Again, a keyword term that you might have to look it up on Google. This is called SEMVer, where first you have major, then you have minor, then you have patch. Let's say you are running on 4.2.1, right? You have a bug, you fix the bug, it will become 4.2.2, right? You're just going to update that small number at the end. You just update the patch version. Let us say there is a new feature. It's not simply a simple change. There are new things that have been added to that particular software, right? Or that particular app or the server, whatever it is. It could be a game, it could be website, whatever it is, right? Now, then you would update the minor to, then it would become 4.3.0. Then you would reset the patch again. Let us say you have completely rewritten your app. The previous app does not work with the new app. Then it will become 5.0, 5.0.0. This system is called as semantic versioning. It will be used a lot when you might be downloading a lot of Python packages, right? PyPy. In that you would see the version number. This is what the version number means. Well, in Python it is not strictly followed. It is not strictly going to be with this meaning. But in JavaScript you will see it is absolutely strict. If your npm install anything, it is going to follow this versioning system, where just by looking at the version you will know whether to update to this version or not. How many new features you are getting, whether you are getting new features, whether it has any bugs, or does it fix any bugs, just by looking at the versioning. So for big software, how you release it is also very, very important. Then you have fault tolerancy and redundancy. We've circled back to what we were talking from the beginning. In fault tolerancy and redundancy, now imagine you've made an amazing app, you've built everything, people are using it, and now you want to safeguard it so that it doesn't go down just magically. It doesn't vanish out of internet. So you can do three basic things that are absolutely required, that every single company does, right? Every single big app uses. First one is having frequent backups, right? Taking a backup can be as simple as simply copying your app into a Google Drive, making it a zip file, and you're done. And it can be as complicated as having a backup system, which is a software that is doing the backups for you, and it only backups the difference. Or there are so many algorithms, there are so many ways to backup, but ideally you should be backing it up. And the biggest criteria is, if you have a backup, it should not be 9 hours for you to retrieve the backup again. That should not be the case. That's a very poor strategy. So you need to back up in a certain way where it is easy for you to take the backup, and it is also easy for you to restore the backup again. In case of a catastrophe where your database got deleted or something like that, it should be easy for you to restore the backup. So that is there. Then the next word that you may hear in a lot of companies is automatic failover. Have you heard about it? How many people? Automatic failover? 1%, 2%, 3%, okay, wonderful. Cool. So automatic failover is, let us say you have a server in the US and there is a bug there, it is not working. Automatic failover is a software that you have built for your app that will automatically start using a different version of your app if the latest one fails, or disabling that feature and using a more primitive feature. For example, you have Instagram, you're using Instagram, tagging in Instagram has failed. It is not working. Tags are not being rendered as they should be. The automatic failover, for an example, would be mentions, at mentions in your Instagram content, right? Those would still work. It's a different system. That is what we call as automatic failover. When the main feature that you are writing did not work, and there is something else that it is falling back to. It is not simply vanishing out of thin air. No, now you can't do this. Will be a bad design. You can't scale to a lot of people with that design. right? So you would want to have automatic failover, where the main feature that we wanted is not working as expected. Now you are basically dropping it down to a different, much more smaller feature, or you're pushing the traffic to a different server, right? Then you have replicas. Replicas are nothing but simply copies, entire infrastructure copies. YouTube and Google and Instagram, you've seen, they never go down. Very rarely you will see Instagram is down, GitHub is down. One of the great examples. Why? Because GitHub maintains replicas. These are exact set of complete infrastructure. All of the things that I've told you till now, they will maintain multiple sets of these in different geolocations, in different places of the world, so that if one place is not working, automatic failover to a different place. So seamless happens, you don't even know that it actually happened. I mean, as engineers, we get very critical warnings that, something failed and it has fallen over. But to users, it will not even be visible. That is replicas. And that is how we scale an app that you have built in your home to millions of people, and if it worked, to billions of people.